I have a number of toolbars open. I've opened the different toolbars just from the view menu. The main LP360 toolbar is the one at the top of my view. The display and navigation toolbar is the one on the left side of my view. The viewer integration toolbar is the one on the most left hand or right hand side of the screen. And then I'm gonna turn off the other ones because we don't need them right now, and I'll turn them on as we need them. I had a TrueView Evo license when I first pulled this up, so that's why mine says Evo and not LP360. Yours will say LP360. So this is our main toolbar at the top. And the first indication that we've got a license is you're going to see that the Add Data button here is active. And that will allow us to add any type of data except for a WMS layer. WMS layer is going to be a separate button for adding in a WMS layer to a project. If you don't have the Add Data button, that means you don't have a license. Go back to License Manager, make sure you've checked out an advanced floating license. If you don't have, if you've got the plus button for adding rasters, LAS data, raster data feature layer, but you don't have the WMS layer, then that indicates that you have a viewer license. And again, go change the license level, make sure you get advanced floating license checked out. We're going to go ahead and add the LAS file that we downloaded. So if you click the Add button, Add Data, on the way we've got this structured is the different data types have their own tab. You can add data from more than one tab at the same time. You just got to alternate the tabs to add. We're going to add in the LAS file by clicking on the green plus button and browsing to our LP100 folder, where I'll find the LP100 LAS file that I downloaded. We do filter by LAS. So if you're using the file in the backup folder, you'll need to toggle in order to be able to see the LAZ file. And as I mentioned, if you do pick the LAZ file, then the only difference here is that before it loads the LAS, it first has to decompress the LAZ into an LAS file, and it automatically handled that. And when it does that, it also maintains a link. So if you make a change to the LAS, when you go to close out of your project, it'll ask you if you want to save that back into an LAZ format. So we'll open up the LP100 LAS file. That adds it into, like this. Your dialog probably looks like this one, where we have a limited view of some information for the LAS file. It's going to tell us what layer it's going to create in the map or add to the map. And it'll tell us the version and the PDRF. So that's the LAS version and the point data record format. That's going to, that helps tell why things end up on different layers. In the top right hand side of the add files dialog is this double greater than symbol. That allows you to expand from the basic columns into the advanced columns, and the advanced columns will display more information from the header of the LAS file. So we can see, for instance, this LAS file came from, is in UTM 15, orthometric NEB88, geoid 03, and that's how the data existed on the LAS, on the LIDAR server. So that's the format, that's the coordinate system or spatial reference system for that data set. There's other information in here as well, such as this is an older data set, right? It's 2006, so the GPS time format is in GPS week seconds. And then there's just some other ancillary information that corresponds with that data set. So there's just some info here if you needed to look at it. We can open up this data in two formats. We can either open it for read-write, or we can open it for read-only. It just depends what you're trying to do. Read-only is nice because we can open, you can open a read-only file from multiple multiple instances can look at that same file. Read-write can only be opened one occasion, and we're going to make modifications if we open read-write. So I typically will always open read-only unless I'm intentionally trying to modify a file. Modifications in LP360 happen on with the changes that you make. There is no save button back to the LAS file. So opening the correct, using the correct open setting will help you from accidentally changing a file that you didn't mean to change. The load setting is, do we want to load? So what we're doing, we kind of have two concepts here. One is adding the files to LP360, and then the second portion of that would be loading the points from that file into LP360. I usually start by first loading my footprint only. That allows me to check and see if there are any problems before we have any, before you encounter any kind of problem. It kind of allows you to check the data and isolate it before you get to that point. The load footprints only will also help if you're loading a large number of files. If you're trying to open, say, maybe a watershed, that allows you to bring it all up, make sure all the data matches, that all into the right formats, kind of get all the checks done on the files themselves before you try to start loading data from those files. There are different options. Some options are here to make sure that, if we're adding data in, that we add it into an existing layer. So if I'm, add something in the other side, I need another piece of information, then it's like I can download another file, add it to the same one. Sometimes there are differences in the spatial reference system that are not meaningful differences. A spatial reference system that has, they get really complex, and so it might just have something like a slight change in the name. And we can just tell it, oh no, I know what the difference is, and it's not meaningful, so ignore it. So make sure you put them on the same layers. In LP360, we use pyramids. This is our overviews of the files. This is what allows us to load in basically limitless amount of LIDAR, where we can just choose an appropriate pyramid level to allow us to view very large areas of data. The pyramid default is to do a thinning of 16. And basically what that means, you can think of that as the top point on the pyramid, there's 1 point. The next level has 16 points. And then for every 16 points on the second level, there are 16 points for each of those 16 points on the third level. The smaller the number, the bigger your pyramid file will need to be to handle the different levels. But what that also allows you to do is open up larger areas of data. And it allows you, as you move around within the data set, to get a good idea of what the data is without needing to be all the way zoomed in on the data set. So that's where this plays a bit of a role. I suggest that you always pyramid. If you don't pyramid, then LP360 has to read all of the files before it can display anything to you, and things can get pretty slow. There is a way to pyramid outside of this to do some prep work if you're working with large data sets, because it does take a little bit of time to do the pyramids. So make sure you always have pyramiding turned on. Let's go ahead and OK. So we've added our LAS file. We're opening for read only. I'm loading the the footprints only, and we're going to pyramid that at a thinning of 16. The first thing that LP360 is going to do is create the pyramids that are necessary, and then it's going to display the footprint because I told it to load footprints only. The reason I load the footprint only is I can do some things in here very quickly. It doesn't take any time to load, especially if I'm loading a very large amount of data. So the first thing I want to do is go and go to File, Project Settings. Project Settings, my dialog just has a new option on it, so don't worry too much about that. But you should have a project path that was set automatically. That project path we set based on where the LAS data is located. There should be a spatial reference system that has been set And that spatial reference system was set automatically based off of the LIDAR data. So because the LIDAR data, the LAS file had a nice, properly formatted spatial reference system defined in there, then LP360 was able to use that to configure your project automatically. So we've kind of set up the project information for you. By default, LP360 is going to use the active LAS layer as your spatial reference system for the map. And so you'll see, because my spatial reference system here is in UTM 15 meters, then my map is down here at the bottom center is also in meters. Yeah. First thing I should do is do a file, save project as, and save myself an LP0100. I like to put project in the name of it for this XML, because throughout the product we use XML files for storing different settings, and by putting what that XML file is in the name of the XML, it helps me keep track of what all these different XML files I have in a project. It's important to save out a project, because there are places that we're going to use the project information. And in fact, in the 2021 release, you'll see the kind of a new interface going in where we'll create the project a little more automated for you. Just because there's becoming more and more things that we're doing that kind of is better done if we already have a project saved. So I just always say, just save the project first. The other thing that I like to do is add a WMS layer so I can verify. So I click on the Add WMS in the top center of my main LP360 toolbar, and I can pick from an available list of pre-built WMS layers that are built in, or you can hit the custom WMS layer and create your own using the WMS manager, where you're able to specify the URI or URL that you're using and the layers that you want to pull from that. So you've got options here for customization. For today, let's just go ahead and use the Bing aerial with labels. And if I've done everything correct so far, then this image should look the same as what I saw in LIDAR server. So I've pulled down some data in the correct location, or I've added the correct data into LP360. LP360 projects do not save automatically. That's the only part that doesn't save automatically. So you do want to, if you make certain changes, remember to do a save project, or a Control-S will save the project for you as well. So if I add a layer, then I probably want to save the project, update it. Right. The boundary that you see is a boundary that's comes from the min-max extents of the LIDAR data. So if you have multiple LAS files, you'll see multiple boundaries. That's controlled by this button called Display Boundaries. If I toggle that on and off. So you may see in some cases that you have overlapping boundaries displayed in LP360, but it doesn't necessarily mean that you have overlapping data. It just depends on kind of what the min-max extents of the data are in the header of each file as to where that goes. So it depends on the arrangement of the files. There's not any boundary that gives you the exact outline of what your data footprint is. That's just something to keep in mind. On the we have this concept of an active LAS layer. So you can have multiple LAS layers in your project, and the LP360 tools, whether those are the tools in the toolbar, or when we get into looking at some of the other views, all of that information comes from what is the active LAS layer. There is a toggle to the right side of the active LAS layer where you can put it in single LAS mode, and Then if we have multiple LAS layers and we toggle between them on the list, then it turns them on and off in the map display as well, so that what I'm seeing in the map, it corresponds with what's my active layer. I usually find that's a helpful thing to do. There are several tools that exist on a right-click menu for layers, and some of them are unique to the right-click menu. Some of them, like LAS File Analyst, also exist as tools in the toolbars, right? So either way, I can right-click on the layer and say LAS File Analyst, or you can hit the hammer and crescent wrench, and it'll bring up the LAS File Analyst for the active LAS layer. LAS File Analyst is handy because it gives us a way to look at what data files are on our LAS layer. We can look at the header information by turning on the first column. A lot of information, so the buttons on the left-hand side here enable us to turn things on and off as we want to look at it. And so if we, if we're trying to remember what things were, we can go back here, and this kind of gives us what information was in the main toolbar, right? Or sorry, in the original add files dialog, right? And second. I think I lost you. Okay. Technical problem, but hopefully, can you hear me okay?
Yeah, we can still hear you, still seeing your screen. Everything seems okay on this end.
All right, good. Just switched over okay then. All right, so we have LAS File Analyst, like I said, just gives you a way to get back to that list view. There's also a lot of other capabilities in LAS File Analyst. We can do things like we can select a file, and this first column shows us whether it's scanned or not. We can scan the information of a file. That has LP360 go through every point in the file and construct a set of information based on that. So we can show and hide the scan columns when this is green. Right. We can multi-select files in this display using Shift and Control, if you want to scan multiple files. And so one of the things we can look at here is if we scroll through our scanned results, it'll do things like tell us, does our file contain any flags? Where flags are part of the classification of a LIDAR point. So in the LAS format, you have a code, which helps us tell is a point ground, canopy, whatever else. And it is also potential that there could be a flag associated with it, which can give us information. For instance, in this case here, we have several points that are flagged as overlap. And that usually means, when we fly to flight lines, there's a small area of overlap between the flight lines that is used for matching those flight lines together and ensuring that we've got good relative fit in our, from our different data collection. Then those are usually flagged as overlap so that we're typically when we're working with data, we don't want to have that extra density in the overlap area. And so you'll see that a lot of times with the data sets. So that way we can ignore those points and just work with the main points in the more accurate points in the meat or in the closer to nadir portion of the flight lines. So you get some different information like that. There's a section here that'll list off the classes in the data set. So this data set, when we looked at it in LIDAR server on the projects list, had told us it was height segmented. So I would expect it has ground, and then so classes 2, 3, 4, and 5, because 3, 4, 5 is typically what height segmentation is put into. But we can see that in addition to that, we have the class 6, where class 6 is the building class according to the LAS specification. We also have class 7 points. That's noise. in the specification, and then we have some class 1. Class 1 is usually reserved for points that have been unclassified. They have no class to them, that haven't been assigned anything. There's also other information here, scan angles, point source ID. Point source ID with aerial data is typically referenced to the flight line number. So there's some just information we can see there. We can see that this data didn't have any color information in it. Those, min-max, so those columns are 0, so they don't exist. So it just gives you a way of looking at some different information. There's a whole analysis piece here. So if you wanted to look at the page with the hand, you'll see throughout the product that typically refers to the options for whatever dialogue that you're on. And so if I look at the analysis, there are a number of checks that we can do looking for different criteria about whether this LAS file fits the certain things or contains piece of information. LAS File Analyst also has some additional functions available in it for repairing information, so we can change the values that's associated in a file or editing the information in here. One thing that you may find useful is part of the edit tools here in LAS File Analyst allows you to set point source ID. And sometimes when you're trying to compare data from, say, temporally from different years, then it could be helpful to be able to kind of take a piece of the data, reassign a point source ID where you can assign that point source ID by year, right? So I can say, oh, my 2006 data is point source ID 2006, and my 2021 data is going to be point source 2021, and then it's easy for me to check and when I'm looking and displaying those and trying to do comparisons between those different data sets. Just something for the back of your mind. We won't use that today. So I'm going to close out of LAS File Analyst now that I have a bit of an understanding of what point information is here. I've got return information. Like I said, I've got overlap points, and I have classes 1 through 7.